question asks how many receptacles can be installed on a 20 amp 115 volt circuit in a commercial office building. The correct answer is 12. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and prevent overloading circuits. Understanding these guidelines is crucial for electrical professionals and anyone working with electrical systems. The NEC specifies that the maximum load on a 20 amp 115 volt circuit is 2400 watts. This is derived from the formula power equals voltage times amperage, so 115 volts multiplied by 20 amps equals 2300 watts. However, the NEC allows for 80% continuous load, which is what the 2400 watts comes from. The NEC also provides a standard wattage rating for general use receptacles. This rating is used to calculate the number of receptacles allowed on a circuit. According to the NEC, each general use receptacle is typically rated for 180 watts. This rating is a conservative estimate that accounts for the potential load that could be plugged into the receptacle. To determine the maximum number of receptacles that can be installed on a 20 amp 115 volt circuit, you divide the maximum allowable load of the circuit, which is 2400 watts, by the wattage rating of each receptacle, which is 180 watts. So 2400 watts divided by 180 watts per receptacle equals 13.33 receptacles. Since you cannot install a fraction of a receptacle, you must round down to the nearest whole number. Therefore, the maximum number of receptacles that can be installed on a 20 amp 115 volt circuit in a commercial office building is 12. It is important to note that this calculation assumes that all the receptacles are general use receptacles. If the circuit also serves other loads, such as lighting or appliances, the number of receptacles must be reduced accordingly to stay within the maximum allowable load of the circuit. The NEC provides detailed guidelines for calculating the load on a circuit and ensuring that it is not overloaded. Overloading a circuit can lead to overheating, which is a fire hazard, or cause breakers to trip, causing an interruption in power. The calculation ensures the 20 amp circuit will not exceed its maximum load rating. It is important to refer to the latest edition of the NEC for the most up-to-date information and guidelines. Electrical codes and standards can change over time, so it is crucial to stay informed of the latest requirements. In summary, to determine the maximum number of receptacles on a 20 amp 115 volt circuit, divide the maximum circuit load in watts by the volt amp rating per receptacle. The result is the maximum quantity of receptacles that can be installed. In this case, 2400 watts divided by 180 watts per receptacle equals 13.33 receptacles, so the answer is 12 receptacles. The 180 volt amp per receptacle rule is a general guideline, and there may be exceptions depending on the specific application and local electrical codes. Always consult the latest edition of the NEC and local electrical codes for specific requirements. Here are some additional factors to consider when determining the number of receptacles on a circuit. Firstly, the type of load. If the circuit will be used to power heavy loads, such as appliances or power tools, you will need to reduce the number of receptacles accordingly. Secondly, the size of the building. In a large building, you may need to install more circuits to provide adequate power to all areas. Thirdly, the local electrical codes. Local electrical codes may have additional requirements that you must follow. Always consult a qualified electrician to ensure that your electrical system is safe and meets all applicable codes. Some examples of other loads that might affect the number of receptacles permitted are lighting fixtures, which can draw a significant amount of power, especially if they are incandescent or older fluorescent fixtures. Modern LED lighting is more energy efficient and may have a smaller impact on the overall load. Another example is dedicated equipment. Certain areas may require dedicated circuits for equipment such as computers, printers, or other office machines. These dedicated circuits should be factored into the overall electrical plan. Heating and cooling systems, especially space heaters or window air conditioners, can draw a large amount of power and may necessitate separate circuits. Also consider the potential for future expansion. If there is a possibility that the space will be reconfigured or that new equipment will be added, It is a good idea to plan for additional circuits to avoid overloading existing ones. The NEC provides guidelines for calculating the total load on a circuit, taking into account all connected devices and appliances. This calculation is essential for ensuring that the circuit is not overloaded. To determine the total load, list all the devices and appliances that will be connected to the circuit and their respective power ratings in watts. For devices that do not have a power rating in watts, you can calculate it by multiplying the voltage in volts by the current in amps. Add up the power ratings of all the devices and appliances to get the total load in watts. Compare the total load in watts to the maximum allowable load of the circuit. The maximum allowable load is typically 80% of the circuit's capacity. If the total load exceeds the maximum allowable load, you will need to reduce the number of devices and appliances on the circuit or install a new circuit. Here's a step-by-step breakdown of calculating receptacle quantity 1. Determine the circuit amperage and voltage, in this case 20 amps at 115 volts. 2. Calculate the maximum load in the circuit. For a 20 amp circuit at 115 volts, this is typically 2400 watts. 3. Determine the volt-amp rating per receptacle. According to the NEC, a general use receptacle is rated for 180 volt amps. 4. Divide the maximum load by the volt-amp rating per receptacle. In this case, 2400 watts divided by 180 volt amps per receptacle equals 13.33 receptacles. 5. Round down to the nearest whole number. Since you cannot install a fraction of a receptacle, the maximum number of receptacles is 12. Additional considerations include the continuous load. If the circuit is expected to have a continuous load, which is defined as a load that operates for 3 hours or more at a time, you may need to reduce the number of receptacles even further. The NEC specifies that the continuous load should not exceed 80% of the circuit's capacity. Also, the location of receptacles. Consider the location of the receptacles and the types of devices that will be plugged into them. For example, if the receptacles are located in a kitchen or bathroom, they may need to be GFCI, ground fault circuit interrupter protected. Also, special purpose receptacles. If the circuit will be used to power special purpose equipment, such as a computer or a printer, you may need to use dedicated circuits or receptacles with specific ratings. Remember that the NEC is a comprehensive set of guidelines that covers a wide range of electrical installations. It is important to consult the latest edition of the NEC and local electrical codes for specific requirements. The NEC also addresses the spacing of receptacles in dwelling units to ensure that appliances can be plugged in without the use of extension cords. While this requirement is primarily for residential applications, it is a good practice to consider in commercial settings as well. The goal is to provide sufficient receptacles so that occupants do not need to rely on extension cords, which can be a safety hazard. Extension cords can be easily damaged, overloaded, or create tripping hazards. Another important aspect to consider is the type of wiring used for the circuit. The NEC specifies the types of conductors, cables, and wiring methods that are permitted for different applications. The wiring must be properly sized to handle the expected load and must be installed in accordance with the NEC requirements. Factors such as the ambient temperature, the type of insulation, and the number of conductors in a raceway can affect the ampacity of the conductors. It is crucial to select the appropriate wiring and install it correctly to ensure the safety and reliability of the electrical system. The NEC also addresses the overcurrent protection of circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. The overcurrent protection device must be properly sized to match the ampacity of the circuit conductors. If the overcurrent protection device is too large, it will not provide adequate protection. If it is too small, it will trip unnecessarily. The NEC provides detailed guidelines for selecting and installing overcurrent protection devices. Grounding is another critical aspect of electrical safety. The NEC requires that all electrical equipment and systems be properly grounded to provide a path for fault current to flow back to the source. This helps to prevent electrical shock hazards and reduces the risk of fire. The grounding system must be installed in accordance with the NEC requirements, and it must be regularly inspected to ensure that it is functioning properly. Another aspect to note is the use of arc fault circuit interrupters, or SIs. SIs are designed to protect against arc faults, which are a common cause of electrical fires. The NEC requires SIs in certain locations, such as bedrooms and living areas. SIs can detect arc faults and quickly de-energize the circuit, preventing a fire from starting. Finally, remember that electrical work can be dangerous if it is not done properly. It is always best to consult a qualified electrician for any electrical work that you are not comfortable doing yourself. A qualified electrician will have the knowledge, skills, and experience to ensure that the work is done safely and in accordance with the NEC and local electrical codes. They will also be able to identify potential hazards and take steps to mitigate them.